Welcome. We're going to do a recap over C# and Unity, covering the basics of C# coding and some of the tools inside of Unity. Just real quick. So we're going to do a 2D project, name it Coding Practice, to our desktop is fine, and go ahead and create this project. We're going to start by creating an empty object. So let's go ahead and in the hierarchy, right-click, and we're going to start with the empty, an empty game object. So what is the first guideline that we need to follow whenever we create an empty object, or in many other cases, importing other objects? And that's that we want to reset the transforms. You can also reset the position or rotation or scale separately if needed. We're just going to reset this. And let's name this Pizza. Next question. How do we make this a 2D sprite game object? Well, that would depend on the components, because this game object is empty besides the transform component. So we'll add, and there's all kinds of components we can add, but we'll type in sprite and we can see a list here. So if we want to do a 2D sprite and we want to give it a certain picture, right? It's going to be something in our game. We would get the sprite renderer, right? You could look up renderer, or the process of rendering, which is making the image out of something. It's a still image. Even with animations, are rendering each frame to make the whole animation a video. So our first one with the sprite renderer, this component, we have these variables here where we can assign a sprite. So if we click the target, we can see by default, we have a few here. So we could just use the default UI sprite or a knob. Doesn't really matter quite at this point here. And then we have color, which we can easily, I gotta move my windows here. We could just change and you can see it's really, really tiny here. So I'm going to press W and move it over, and then press R for scale or rail. I'm just going to move this up here. There we go. You can see it's a red color right now. And let's change this back to white for a second. Let's put a custom sprite in. So how do we import some artwork for this? And I have a sample here. So we're going to throw this in. And here we have a pizza. And this pizza slice graphic, because this is a 2D project, the default for the import of this image is going to be a sprite 2D, which is what we want for this particular one. And these are just for the import settings. So we can go to our pizza game object, and we just want to use the sprite here. So I'm going to drag this pizza slice here. Boop. Whoa, and that's where we can see our scale now is gigantic because of our imported sprite. So what we could do is just maybe shrink this back down, and we can see 1 is pretty solid. Maybe we'll even do 0.5 and 0.5 on the X and the Y for right now. So we have our pizza slice. Now you can see if we tint it red, though, it's taking the image and applying a color over the graphic. And so it kind of tints it, but it is replacing a lot of the coloring to be pretty red. We can reduce the alpha, which is the transparency of that. We're going to leave it white so we can just have a pizza. Then we're going to go ahead and create another one, but this time let's create a 3D object. We're going to create a cube. And I'm going to scale this up, pressing R to scale it, W then to use the move tool. And then I'm going to, we could reset the transforms. I probably should have done that first. But here I'm just going to go ahead and rotate this a little bit to get the angle. And I'm going to scale it in to kind of make it look a little bit more like the pizza box per se. Now, the thing to keep in mind here, since it's a 2D project, we don't have any 3D lights set up yet, so you can notice there's no shading. If we look at the material, it is got this white material that's default, but our box doesn't have, it's not black from there being no light, but it's also not white. So there is something going on with the lighting, but it's a bit different in 2D than it is 3D. Something to keep in mind. The differences between the two, starting to compare them. So now, let's go ahead and we're going to create our first script here, our first recap. We're going to create a C# script, and we're going to call this destroy basics. And guideline would be name your script right the first time, so you don't have to rename it because you have to rename it inside of the script as well. The class name. But we got that. We're going to go ahead and put this on our pizza. Put it right there. Smack dab right on the bottom. We're going to double click. Doo-doo-doo. And we get our handy dandy in my other window. But here it is. What do you know? And we're going to just go ahead and get rid of our start function and the comments. And so here our class name needs to be named the same. Go ahead and save this. And then now the first thing that we're going to do is just the most basic destroy. We want to destroy the object that has this script, which is the pizza. The pizza has this object on it. So we simply can just call destroy, which comes from Unity here. You can see if we hover over it, it says removes a game object, component, or asset. So then what do we want to destroy? So here we just list, it says the object. What is the object that you want to destroy? This is the most basic form of destroy. So we can simply type in game object, which is, if we go back to that, you can see right here when we hover our mouse over it, it lets us know this is the game object this component is attached to. It's talking about the script component. A component is always attached to a game object. So because this destroy basic script is on our pizza, in update, as soon as it runs update, it will delete our pizza. Now we may want it to delete via a key or a button on the keyboard. So here we can go to type in, we'll have an if statement, because if we press a key, then we want it to destroy our game object. Now to get more information, in this case, get key or get button is going to come from our inputs. One shortcut to doing this is we can just click your mouse. You don't have to highlight it, but if you just put your mouse there, you can go up to help and then get the Unity API reference documentation. This is a link to the Unity documentation. When that populates, we'll get more information about Unity's inputs. And here there's a bunch of links. So we have input, and it's got a bunch of different information here to help you troubleshoot and also figure out what you may need to know. So here we have like an example here for get button down. We keep going and we can look at the static methods. So these methods, we have stuff like get access, get button. This returns true while the virtual button identified by button name is held down. And then we have get key, which returns true while the user holds down the key identified by name. So if we take a look at get key, it gives you additional information that you need to know. So stuff like iOS or tvOS, due to the limitations of the platform, it gives you some extra information that you need to know. So this can be very, very, very useful. And here we have it by name, get key by name, but then you have typing in the key code. And this gives you some information. Returns true while the user holds down the key. So if you press the button once or hold it down, it will do something depending on your code. So that's great. Let's go ahead and put that in. So input.get. So you can already see the IntelliSense. We're getting some recommendations here. So we're going to use get key. And then we need to put in the key code. Now, as soon as I do the parentheses, you can see it's not adding the other parentheses here. So we got to be careful and make sure we add that in. To do the key code, it's capital K, key code dot, and then the name of the key. In this case, I already know it's a capital S, and then for space. So now we can save this, and you'd want to test it out, but I've already done this 6 or 7 times. So when you go in and press play, it's going to delete the pizza because our script, well, not yet. So select our pizza, drag the script on it. There we have our script. Now, if we press play and hit the space bar, it will delete the pizza. I guess it might as well show it, right? Boom. Looks like I accidentally put it on the pizza box. So let's go ahead and remove that. One of the things that you need to know is, what about this destroy script if I want to destroy something else that does not have this script component? Because maybe I don't want to put this on every single object. Maybe there's just a specific thing. So I'm going to name my cube here pizza box. I'm going to go back to my pizza so you can see the script updates. And I'm going to go back to my script. So let's not do that. So here's what I want you to do. Challenge. Type in a variable that we can assign the pizza box to and destroy the pizza box instead of the pizza. So pause this and try to type that in. All right, and now, whether you were struggling or you just wanted to confirm that was right, so we need to put in a variable first, and I want to see this in the inspector. So we could do 2 things. One, we could do public, but then that means other scripts would be able to have access to this variable. So for right now, I don't want other things to have access to it. I just want to see it in the inspector. So I'm going to serialize it by using this attribute, serialize field. And then this is a game object. And I'm going to name the variable object to destroy, because this is whatever we want to destroy, this variable. So right now, if I copy this and then put it in here, when we press the space button, it's going to destroy this variable. But wait. If we were to play the game right now, we will get an error when I press the space bar. So if I press the space bar, I will get an error for null reference exception. Lovely. It's not giving me an error this time around. But usually it does. What do you know? So the problem here is that there is no object assigned to this variable. Object to destroy, what? None. So I'm going to drag in my pizza box, or you can use the little target symbol. Now, if we press play, maybe I didn't save my script. Aha! It works. Press the space bar and the pizza box is deleted. But because it's deleted, also now it can't can't destroy it again because it already destroyed it, so now it's missing. But a quick intro to that. Now we're able to destroy a separate object without moving the script. Now let's go to our project window, and we're going to create another C# script and name this one color change. And then we're going to open that up. And actually, on our pizza, let's drag this color change script onto our pizza. So we want to change the color of the pizza. Again, I'm going to delete the start and the comments. And we're going to start with our if statement. If input dot get key, and then which key code, we're going to do R for red, Romeo, and because we're going to change the color to red from white, because currently it is white. So we want to talk about the dot syntax. So for instance, if I was to give you a location using dot syntax, it might be something like, let's see, Hawaii, then maybe a specific county, then a specific city, then and I'd put a dot, so I'd be Hawaii dot the county dot the city dot, and that is boiling it down to the location. Just like if I was using dot syntax, as a rough example, if I said unity dot project window dot assets dot scenes folder dot sample scene. So we're going to use that same dot syntax in our coding for our color change. Now we want to access a specific variable. So we start looking at our components and the data that we have on there. And we look at, okay, this color change is, the script is on the pizza game object. So the next thing that I need to do is I have a special component called the sprite renderer, and you can see here there's the color. That's what I want to change. So the first thing that I have to do before I can do the dot syntax is I need to get this component to access it. So I could type in get component. Again, for more information, you can go to the help documentation, because there could be a sample question or something that you might need to do, like get a specific component like the animator and delete just that component rather than deleting the whole object. So maybe we want to destroy a certain component. Destroy is going to have specific things so you can find more information about. Just like get component, we can get different components, and then there's several things we can do after getting the component. So here I want to go in and get the component. Now, you might start off with renderer because you notice that it does have a renderer. The only problem is here, this is general functionality for all renderers. So it's not going to have specific functionality, just general. So in this case, we look and it's spelled, and we want to make sure we capitalize and spell correctly. Of course, you can always search for this online or check the Unity documentation. But we want to get the sprite renderer component. Now this is a method, so get component with our parentheses. Then after we get that component, we don't just have to end our statement, because we first want to assign, we got to get the current color in that variable and assign the color we want. So to do that, we can simply use our dot syntax. So we get the component, and then we could do, say, dot sprite, and we could actually change the sprite. But that's not what we want to do. If we do dot color, you can see rendering color for the sprite graphic. So we'll do color, and then we have our symbol for assigning, and then we need to assign a new color. Now Unity already has colors set up in a way that it's really easy to assign them. Simple. colors, and that is if we type in color dot, even if you do lowercase, it'll help correct you, because this is not a variable, it's a structure, and you can see it represents the RGBA, red, green, blue, alpha. And then we can just call the specific color. So for instance, if we did, you got black, you've got blue, we've got clear, cyan, gray. So we want to do red. There you go. And then it even gives you the number value if we were putting that set of data in parentheses, but we can just do dot red and in the statement. So now if we save this playtest, once we press R, the sprite is going to change to red, and it's going to stay red. So maybe let's make it just stay red when we are holding the key down, or I should just say pressing the key. And then when we're not pressing the key, we want it to turn white. So remember again, get key is while you're pressing down the key. It's holding down the key. So it's still different than get key down. So what we want to say is, okay, we get key for the R. If we're not holding it down, then we just want it to go back to white. So we'll do an else statement. So that means anything else. If you're doing anything other than pressing R, then we want it to turn white. So we can simply copy this line of code and just change red to white. Then when we play test, we press R. So if I just press it, you can see it flashes. But if I hold it down, it stays red. I let off, and it goes back to white. Now you may notice I could also do get key down, and then for this second if statement, I could do get key up. Similar. And it will have its uses depending on what you are coding. But for this example, this method works a little bit more readable and efficient. So we're going to save that and come back. So now we're going to create another C# script, and we're going to name this color change material. And this one, we're going to put this on the pizza box. And then open this up. So what I want you to do is see if you can figure out how you could change the color of the pizza box to green. So you can easily start with your input for G. And then what do you need to do to get this to actually turn green? So go ahead and pause the video and try to troubleshoot and figure that out. All right. Hope you took a try at that. So we know, right, it's going to be get component because we need to get a component somewhere to change the color. And you'll notice there's, on the object, there's two kind of things that you would want to be looking at. So our box collider doesn't have anything with that. Our script doesn't have something because that's a different controller. We've got the transform. We've got this cube mesh filter. That's just the 3D mesh. Then we have the mesh renderer. So renderer, again, this renders the object. So that means that would be visually, what does it look like? So that has access to materials here. And then we have the material at the bottom, which does have this albedo white color. So you may have looked at trying to get the material and change the color. This one's a little bit different than a sprite. But what we're going to do is we can just get the general renderer. And then from the general renderer, it is rendering the material. So in this case, it's not a sprite renderer or the mesh renderer that has the color on it. It's the material that has the color for a 3D object. So for that, I have to do dot material. Right, if we hover our mouse over, you can see it returns the instantiated material assigned to the renderer. Then we can go of the material. The material has a lot of different variables on it that control the overall, the full look of the material. How shiny, how reflective, what normals or height information, if there's any invisibility or see-through portions, transparency, all of that. So we simply, though, are just changing the color. We're not actually dealing with a texture. So for that, we can just do color. And then we assign a color from the color structure. And we're going to do green. And then we can do our else. And change it back to white. Save that and test it out. And you'll see our red still works. And if we press G and hold it down, you can see in the inspector and in the game view and scene view, it turns green. And then when I let off the G, it goes back. Now we're going to talk about the transforms and take a look at some of that information for the pizza. So we're going to right click, create a C# script, and we're going to call this one check position. We'll go ahead and select our pizza, and we're going to put our check position script on the pizza. And now what we want is on the x-axis, right? We can drag this to C. We're going to create a safe zone in the middle. And if we're too far left off the screen, or if we're too far right off the screen. So right now, I might say that's roughly 6. So maybe we'll even do like 7 is maybe a little bit too far to the edge, right? And then -7 is too far left. So let's set that up. So open our check position. We're only going to use our update for this. So inside of our update, we're going to have an if statement. And because this script is on the object, we don't have to type game object, but we can just type in transform. It automatically knows, hey, get the transform position.x. And then we want to see if it is less than -7. If it's less than -7, we then want to say it's too far off the screen. So what we can use for right now is print, which you'll see here. This logs a message to the Unity console. It's identical to debug.log. And that is, the debug has a set of tools. One of those is the log, which logging it to the console, just kind of keeping that information in there. So in this case, we're just going to keep it simple and use print. And we're going to put a message here, which means if we want to use text, a text message, we have to put quotations in our script. So we're going to print, you have gone too far left. And then we'll save this. Now if we click play and go to our console and we take our pizza, we'll press W and we move it over. Once we get over past that 7, you can see the messages piling up. Now that's because I have collapse on. If I turn that off, you'll see it just keeps scrolling and scrolling, printing every frame that update's running. I'll just do collapse. You could just see it's running. So now as soon as we bring it back to the middle, it stops running. So now we want to do that same thing. So we'll just copy this and paste it, but this time we want this to be the far right side of the screen, so we'll just get rid of the negative, and this would have to be greater than 7. And you can see now that if we had multiple positions, this could get very messy. On top of, what about if we're doing this check position for what has the script on it, but what if we wanted to check the position of another object, right? That's going to add another dot syntax, because then I'd have to create a variable, say pizza box, and then I'd have to do pizza box dot transform dot position dot x. And then what if I have 2 conditions, which would be the next one, right, in between, let's say -6 and 6 or -5 and 5, there's going to be 2 conditions. Therefore, it's going to be even longer. So we could cache this into a variable so we don't have such a long name here. And we could do that 2 ways, right? One is we could do a vector 3. So a vector 3 like this, then all we have to do is put, right, position for pose. So we got our pose.x, right? Now that's a little bit shorter, right? But we could shorten it even more, right? Specifically, right now, a vector 3 stores 3 vectors, .x, .y, .z. Right now we only need the x. So we could do this a little bit shorter instead of this. And what we'll do instead is, right, the transforms is always going to be in decimal places, so we'll do a float for this. And we'll, of course, the position, we can't assign an x, y, and z to a float, but we can just say we want the position.x, right? That is going to get the value. Now we could change this variable to say xpos, x position, right? We can shorten this now. And now we have much cleaner code. So we know the x position less than -7 or x position greater than 7. Which allows us now to determine that safe zone area. So we'll copy and paste this here. So for now, I'll just write safe zone. And so what is our safe zone? Well, it's in between 2 things. So in this case, we're going to have a condition of it needs to be less than, but also greater than a number. And we could just use 5 as our example number. And so that could be, so our first would be if it is greater than -5. So if it's -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? But it's not just that. We have a second condition. It's the AND condition. So AND, it has to be greater than -5, but it also has to be less than 5. Now, that would mean it would have to be less than 5. It'd have to be like 4.9. So in that case, I might want to do maybe less than and equals to. It depends on your coding situation, right? It depends on if you want it to be able to equal -5 or that it has to be only greater than or less than. Right, so it just depends. But this is nice and clean. We can save this. And then here, if we click play, it's going to clear this out. You see, right now we're in the safe zone. But if we go to the right, then it says you have gone too far right. And if we go to the left, you've gone too far left. And you can just see the code is running and running and running every frame until I go out. Now, if I'm right in that zone that's in between the two, the left and the safe zone, right, it's not printing anything because it doesn't meet any of these conditions. None of these conditions are met. In that case, we could also do something, okay, if it doesn't meet any of these conditions, then we could simply write an else statement that says, I don't know, whatever we want it to say. So it could be like, you are not in any specific bounds. There you go. And so now we have a message for each zone area on the x-axis per se, invisible zone areas. Next, we're going to create a more complex method where we're adding two numbers and different numbers. So I'm going to create a new C# script, and for now, maybe I'll just do Add2Numbers. Why not? And we'll go ahead and let's create an empty, and I don't know what to call this yet. We'll just put our Add2Numbers on there and open up that script. So above update, we're going to create some variables representing some numbers that we might want to use. So we'll just use whole numbers in this case. So let's set these up. Bananas. Now that we've got that, we can actually change this to our start method. And what we want to start is with how, well, let's do this. Yes. Got distracted. All right, so we're going to create our own custom method in which we're going to add two together. So we're adding two together. So in this case, we want to add, I don't know, maybe we want to add the apples and the pizza together. But you see, we can't just write that in here. We have to have some way to store that. So we're going to create an integer value for, let's see, maybe total food here of what we have. So then it adds those together and we get our total food, right? So essentially write an equation. We get 2 plus 11, we get 13. And it stores that in this value. But it's not going anywhere, right? Right now, we are literally just following directions. Kind of like if my wife gave me directions to clean the house, I just go and clean the house. But if my wife, let's say, says, hey, go and clean up the house and bring me all of the baby equipment, right? Then, in that case, I'm doing an action, but I'm also returning certain things back to my wife. So if we're going to return something, right now we have the return type as void, nothing. It's void of any kind of return. So in this case, what are we returning? Well, we want to return an integer. And if we're returning that, we get an error because right now it doesn't have anything to return. So we have to write a line of code. Return. What are we returning? Total. The total food. Then it returns that to this. So in this case, void start. I need to execute this method. So challenge. How do you call a method to be executed or to run? We just want, let's say we want this to run at the start of the game. Go ahead and put that in here. Whose terrible whispering is that? All right, hope you had some time to do that. We're going to go ahead and execute that. So we'll do our method name, and then our parentheses, and then our semicolon. Oh, I did add two numbers. We need to add two together. There we go. Okay, now it executes that. And then if we want to print this, although it executes that and it's returning that, right now it's not returning that to anything specific, right? So if we want to be able to return this, so maybe here, so we're not confused, we might just put this as total, just name it total for our example here. And then here, let's see, we'll do apples and bananas, so it makes more sense. And maybe I might put, we need to assign this method to a variable. So we could say an integer variable total fruit. And then we're executing this method. It's going to add these two together, which will give us 5. 2 apples, 3 bananas. That'll equal 5. It'll return that and assign it to this variable. So total fruit will equal 5. Then we can say print and since we're doing a variable, we don't need that. We can just say total fruit. Print that. And there we go. We will print that. Now let's say we want to add some text to that, because if we just print that number, we might be like, okay, sure, but I don't know what that is. So in that case, we could come in here and say total fruit is, and then we have to, in order to put these together, total is an integer, but this is a string. So in this case, we're going to have to put the plus, and it will automatically convert the integer into a string so that it can be displayed as text with our string of text here. So it'll say total fruit is 5. Okay, that's great and all, but that's not really super complex. What would be smart is I might want to use this 7 or 8 more times for other things, especially if I turn this into more of a game. So in this case, which is not there yet, that's for sure, but this is just kind of getting a nice recap on things. So what we might want to do is use this method, make it to where we can use this method over and over and over again, because I don't want to copy this and paste it and type in pizza and almonds, okay? Instead, what we want to do is we want to, when you call this method, we're going to say, we'll comment these out. We'll say, hey, when you call this method, you're going to have a num1 and another integer, which will be our num2. And these two integers that you pass in, we're going to add num1 with num2, and then we'll return that total after adding those two together. So then we add these two together. We can say add, and we could do apples and bananas. So instead of adding hard-coded in numbers, we're adding in the variables. So it's like an equation in an equation, right? We got variables inside of variables, you could say. And then we're able to print that. But see, this allows us to also be able to run this again, where we can have another integer, total, let's say, we'll just maybe call this one total food or total lunch items. I don't know. Whatever we would want to make sense of. But then we'd have our add two together. And we would add our pizza and our almonds. And it's going to use that same method. Right? Again, then we would want to print and we just paste this variable in so it'll return that number, and then it'll print that number. There you go. Make sure our alignment's nice and solid. So here you can see how we're using a method that has parameters where we're requiring, hey, when you run this method, you have to include two whole numbers. Then it'll add those together and return it and put it here. Now, a little challenge. Pause the video after this and create a canvas and a text in which you can, instead of printing, send the result to the canvas. All right, so the first thing that we're going to need to do is create a canvas. So we'll go ahead and right click and we can create a canvas. But instead of just creating a canvas, we could just create a text for now. And we'll just do regular text for the moment. And this will be, we'll type in a number and we'll increase our font size. You can see our canvas is here. We'll go ahead and pick our color, which is hard to see because the gray matches with the gray. And maybe we'll just put this, you know what? Let's go up to our anchor point. We can do Shift to set the pivot to the center, which is already there. And then we'll do Alt to move it to that position. And then we're going to center our text and also center it inside the text box here. And just in case, we can grab our rect tool. Can drag this, but I'm going to hold Alt and just kind of make this bigger for what I'm thinking. And then I can increase my font size a little bit more. So sure right now that I wouldn't have more than say 3 or 4 numbers, and so that'll fit perfectly fine. And we could call this our count text. So being that this is our text, if we go back to our script, we're going to have to add in the namespace to be able to get that type of game object. So UnityEngine.UI. And then we're going to need to create a variable for that. So let's create a reference to that UI object, and we'll serialize this, right? So it's still private, but we'll be able to view it in the inspector, assign it, and this will be our text, right, which we're going to call the display count. And so here we could take, maybe we also want to create an integer for the total food. Display count. Now, it wasn't real specific, but we could, at the start of the game, go ahead and set our total food or our total count to equal 0, as if like starting the game, whether it's points or coins or certain items or something, it's set at 0. And then let's create the update function, and we'll get an input so we can have this a little bit more interesting. And we'll do the get button. Let's do get key down. And then the key code. Maybe A for add. Sure, why not? So now, again, when we press the A key, we're going to go ahead and take the total food variable, and we're going to assign taking these two total fruit. Whoops. We'll say total, wait, no, it's total. Oh, we can't actually. We can't actually reference these variables because, if you remember, they're local. So what we could do here, right, instead of starting off with 0, is right here we'll just say, hey, sure, we can start with 0, right, but after we add these all together and print it in the console, then we want to assign that. So we'll take the total fruit and add that with our total lunch items. That'll give us our total food. So then at the start of the game, we have our total food. Then, now that we have our total food, all we need to do is, instead of printing this, we need to assign it to our display count text. So we can simply come down here and say display count dot text, right? This is the dot address. Again, it's going to here and getting our text right here. So currently we put 15. But we'll say, hey, this value needs to be set to, and here we want to make sure it says, do we want it to say that? Nah, let's just put total food. Now we get an error because it says integer to string. So we could just go ahead and put some text, right? And then put in our plus sign. But that means this is going to be one line. We're going to have to make our text box bigger. Oh, and I must have accidentally pressed a B. These two variables were off. Anyway, got that fixed. All right. Here we go. Let's go check this out and see if this works real quick. So we have, let's first make our text box bigger. And then our game object, we might call this count manager, because that's what it's doing right now. Drag it down. Where are we displaying this count? What's the text? So we can drag that in now to assign it. We have our console open. We can clear these out. Let's click play and see what's going on with our code. So we get total fruit is 5, total lunch items is 68, and we've got safe zone being printed. Then if we are in our game view and we press A, total food is 73. Boom. And that concludes this quick update, kind of going over some of these key items. Next, we'll be covering random.range, instantiate, and maybe some stuff with particle system, camera and lights, and a few other tidbits.